Good morning, everyone, and welcome to our webinar. I hope everyone can hear me okay. You're very welcome this morning to our webinar on why you should consider solar thermal in your energy assessment. I'm just letting a few people who are joining just pop in. I'm Julia McDade, COO here at Senergy. And before I hand over to my colleague, Fintan Strain, who's going to take us through the presentation, I just want to take you through a few housekeeping items. The webinar is scheduled for 30 minutes overall. Fintan's presentation is approximately 25 minutes, and that's going to leave us a few minutes at the end for any questions. So in the meantime, all attendee microphones are off. And if you have any comments or any questions that you wish to ask us, can I ask you just to log them in the Q&A function, and we'll try and pick those up at the end. And finally, just to say that the presentation is being recorded and a copy will be emailed to all attendees after the webinar. So I'm just going to hand over now to Fintan.
Good morning, everyone, and welcome to our webinar on solar thermal in industrial applications, and particularly with the reference to energy assessments. So first of all, it's nice to have you all here and we'll talk through solar thermal in general. So before we really get into the details, just a little bit of background about us and what the plan for the information is. Just want to talk a little bit about what solar thermal is, why you might consider it, and I suppose then some practical implications for assessing sites when you're out on site, whether that's with yourself or your clients, and just some key takeaways, if you like, that might be valuable in your next site visits. So just to talk a little bit about Senergy and who we are. Now, so little caveat: this is not a sales pitch in any stretch of the imagination. I suppose our main focus here is just to give you a little bit of information on us and where we come from, and help contextualize the next bits of information on the slides. So we're a small company just outside Belfast, and we specialize in solar thermal. Right from the product end, we have our own products up to installation end, and elements thereafter as well. So one of our key products, actually on the domestic side, is a roof integrated panel that we've developed and patented and have out on primarily trying to address how solar thermal looks, and real nice aesthetic product that we have it flush with the slates and tiles. You can see on the left hand side of the screen there. We then work with on-roof systems, so on-roof solar thermal panels that go above slates and tiles or other roof coverings, both for domestic and commercial applications. We have a big digital element. We're very keen on showing and attributing value to hot water, and we'll talk a little bit more about that in a minute. And then we offer, I suppose, taking all those elements and getting those onto a site in a turnkey solution. So I'll leave the kind of that's just a little bit about us, just to set the scene, I guess. So let's get into it. It was a short, brief webinar. So why would you consider solar thermal? The takeaway line, if you like, what we would like to convey today is, if you or your clients use a lot of hot water, then solar thermal is a very valuable addition to most scenarios. So it's certainly something that should be considered if that is a key element, is your clients or you use a lot of hot water. So, why would you consider solar thermal? So go into the technology a little bit in a minute. Essentially, we're using solar energy to heat hot water, and why would we consider that? Well, in a sense, it's an extremely efficient technology in converting sunlight into hot water, and then that hot water is then, it's a very, very low cost technology once that's up and running. We've only minimal operating and maintenance costs. So it's an extremely efficient technology and simple technology. And we want to do that well and want to show you how you can do that well. It's a really low carbon technology, arguably the lowest of a renewable technology. A well-designed system can accommodate 60% typically of hot water needs throughout the year. Of course, all renewable technologies have their downfalls, and which is why we stipulate 60%. Sunlight's not there throughout the year, and we want to address those weaker points of technologies as much as the strengths, and we're not trying to shy away from those. However, one of the very good points that we can consider is that it integrates well with other technologies, PV, heat pumps, fossil fuels, and they all have their place. And in a modern society that is addressing renewable energies, it's important to recognize that it's not a one technology fits all solution. Our data side of things and just solar thermal in general, when we measure that, when we measure the value, we can bring an awful lot of value to that in the digital side of things, and turn that from a simple functional technology into a real valuable value added asset, which we'll touch on a little bit more shortly. So what is solar thermal? Solar thermal is a simple technology that harnesses solar radiance, which lands on what we call a collector, which is the solar panel. And that collector is a box, typically a metal frame box with insulation, an absorber, and a glass pane on the top. So when the radiance lands on that glass, it passes through it and hits an absorber, which collects that energy. The box itself, to simplify it, essentially acts like a greenhouse, and the temperature within that collector raises. A working fluid passes through the absorber, so it comes in at one temperature, meanders through the absorber and out at a different location a few degrees warmer than it went in. That working fluid circulates in a closed loop and exchanges that heat with a cylinder, a store, or some other use case where that hot water is actually used. And it circulates, once that heat has been given off, it circulates again a few degrees colder and back up to the collector, and the process continues. So a really simple technology in its function, and that's one of the key benefits of it, if you like, as well. Simple and effective. So we'll address a few probably burning questions that you most likely have. One of the most obvious ones is, how much does it cost? And particularly in industrial applications, that is a well, it depends answer, which obviously is not the easiest answer. But in industrial applications, things get a little bit more complex. So I want to take you through those costs as we go through this, and what factors you can look out for and reduce and optimize and that kind of thing. But as a general basis, panels themselves are not that expensive, and it tends to work out about 30% of the cost of a project. You have some control systems in there. You have the cylinder or the tank, the storage vessel, and then a lot of civils costs. So how you get panels to site, where you put them, and plumbing and labor and things like that. And that's the big things that we can reduce. And I want to take you through how we potentially reduce those. Another question people, particularly on the domestic side, will say, well, can we not just use photovoltaics, PV, and a diverter, an eddy diverter or something like that into the immersion? Well, the answer is you can use that. It's quite inefficient. And we'll show you some examples of that later. It tends to be on average about 3 times less efficient. And particularly if you're limited by space, it's a very inefficient means of doing it. And what I would like to convey through this webinar is that PV is very, very good for electrical loads, not good for heat and hot water. That's where solar thermal is, and they're complementary technology. They're not doing the same thing. Finally, what happens in winter? Unfortunately, we just don't get much sun in winter, as you all well know. So we have a bell curve distribution where you have just less irradiance landing on the country in winter, so you need a backup fuel. And that's why I say 60% of the hot water demand through the year is typically met with solar thermal. And we can show you how you can plan that as well. So don't worry about the text in the slide. I put the text in this just for distribution afterwards, and you can look at this. And what I'm trying to show here is the back of the envelope calculations on solar thermal compared to PV. Again, we don't like comparing solar thermal to PV. It's a different technology, but it's something that comes up quite regularly, so we wanted to just address the matter. So just to give you an example of a relatively small commercial installation of about 40 square meters of collector area. And again, back to the envelope calcs, but all the figures are there if you want to look at that later, and they're quite accurate. A typical solar thermal installation in an industrial application will generate about 400 kilowatt hours per meter squared per annum, particularly in this country. And then we can attribute a CO2 saving to that, which is of significant interest to a lot of clients at the moment. That's obviously dependent on what fuel you're displacing. You can see that on the right if you're displacing gas or grid electricity or whatever that may be. The equivalent PV production for the same meter squared area, 40 meters squared, is about a third. So the solar thermal, you are generating about 3 times more kilowatt hours. Obviously, that's hot water. It's a different basically use case compared to electrical loads with PV. But just to give you an approximation of what that might look like. So again, PV, very useful for electrical loads. Keep it at that. Solar thermal, consider that for hot water loads. And where do we use this? Essentially, going back to that first statement, anywhere where there's a large hot water usage, you should be considering it. It's certainly not the solution all the time, but anytime there's a lot of hot water, it's very much worth considering. Industrial process heat is one of those things. We have a big food production industry in this country, and very much useful in those cases. We have a lot of washdowns, cleanings, all that kind of thing. Very, very useful for that. That covers beverages as well, or process heat in breweries or anything like that. Dairy applications where we're washing down after milking, very applicable use case. And then in leisure centres and pool heating, spas and things like that, where we can essentially, it's quite a simple process for exchanging heat with a large body of water. So 3 big use cases to consider. And probably from here on, we'll go into a little bit more details of how we get this in. Just to consider, a lot of you are probably aware of this, but there is financial assistance for a lot of renewable technologies and industrial applications, depending on what side of the border you're at. There's SEAI, cover about 15K, up to about 15K, 30% of the costs. And in the north, there's 2 schemes, one through Invest NI and one through the NI Sustainable Energy Programme, both of which you can look at later. But they do help. They're not deal breakers in many cases, but are very useful to potential clients. So certainly worth considering. Okay. Senergy, our ethos is about adding, showing value to hot water. And we want to convey that in our product offerings. And regardless of what we offer, we want you to start thinking about this as well if you don't already. We engage with a lot of clients, huge hot water users that don't always attribute a value to their water. They might have an energy bill, but not a value to heating hot water. And this is common, particularly in leisure centres, for example. So what we want to do with systems is actually put a number to that. How much is it costing you? How much are you using? And what's your attributable CO2 impact as a result of that? And we can get as granular as you want in that. We could, so many different variables we can measure. As that age-old saying goes, what gets measured gets managed, and that's where we start. And we would like to ask you to engage with your users on this as well. In our daily work, we generate an energy portal. How much energy have you generated from the sun? How much are you using? And then how does that compare with your other energy? In one installation, for example, we found excessive waste in boiler usage and immersion usage. The biggest sin in this country, of course, constant immersion usage. So there's lots of other added benefits outside the solar thermal elements when we're putting this in. So we can get that as detailed and as granular as you like, or as maybe a bit more user-friendly version. So we have our own platform for this, where we simplify measurements, take all that extensive data. We have our own software and algorithms like that, and we put this on a platform where we show carbon savings, cost savings, and even simple things on a domestic scale, like how much hot water have you in your tank, and can I take a shower with it? Can I take 3 showers with it? Whatever the case may be. But again, this is applicable just outside of Senergy as well. Again, the underlying theme here is we want to show a value in hot water. Easy to do with PV, because electricity is easy to measure. Trickier with hot water, which is why it hasn't been done, but we want to bring that to your attention. We have offerings, other people, I'm sure, could do it too. Okay, just looking at some of the technical elements now, going into a little bit more detail and what you might look out for when you're assessing a site. One of the first instances, or what does the system look like, and where do I put potential panels? So we'll look at where do I put potential panels first. So we have 2 options, very similar to PV. We have a ground mount system or a roof mount system, depending on what space is available. And you can put those on pitched roofs, or we can put those on flat roofs, either attaching directly to the roof or with an A-frame. And similar kind of things apply as a PV. You want south facing, ideally inclined at an angle of about 38 degrees, ideally, not always, and free from shading from trees, other buildings, and things like that. Ground mount systems become much more popular as well. There's a multitude of ways we can do that. You can put piles in, you can put ground screws, slabs, precast frames, you name it. There's a multitude of ways to do that depending on local conditions. And you can talk anybody through that if you want. There's ways you can stack them in closer together if you're tight on space. You can raise various rear rows, things like that. But again, just to convey, there's a lot of different options we can consider here for mounting. Okay, so the next thing after getting a rough idea of where we're going to put panels, the next question, I suppose, is then how do we integrate this into either an existing system or a new system? So I just thought I'd run through a few different scenarios here. On a new system, obviously, it's easier to accommodate because we're beginning from scratch. The simplest way is to incorporate the likes of a twin coil cylinder or something like that, where solar feeds the bottom of a storage vessel and a different fuel feeds the top, either oil, gas, heat pump, immersion, something like that for the winter periods, or take primary load during winter periods. And that is a simplified version of a simple system where we have one store and multiple technologies into one store. Then in many industrial applications where existing buildings and existing hot water systems are in place, there are several different variants that we can consider. And I'll just take you through a few, and there's, bear in mind, there's a multitude of combinations we can experience in reality. So on the right-hand side, on an existing site, you might have a hot water store where it's heated by an existing technology, oil, gas, heat pump. And we want to incorporate solar thermal with minimal impact on the existing system. In that case, what we can do is we can potentially put in an additional thermal store just dedicated to the solar system. And that feeds into the existing hot water infrastructure with not too difficult control to do that either. It's a low impact way of integrating within elements that are already in place. We don't always need a store. We can use heat exchangers depending on basically the load. So how much hot water are you using relative to how many, what is your solar thermal system sized at? So in one application, what we do is we pre-feed into a boiler. So there's a huge demand on the boiler side, and with a certain size in this particular example of solar thermal panels, about 50 meters squared, which was preheating an undersized buffer, and that undersized buffer was exchanging some heat with the cold line going into a boiler. So there's one example. Another example could be where we're heating a swimming pool. You mightn't even need a thermal store there. It can be quite a simple system where we just mount panels on a roof and feed directly into a heat exchanger upstream of the fossil fuel heat exchanger for the swimming pool. And that's a very simple system, relatively low cost system, not significant infrastructure involved in that. So there's a multitude of options is what I'm basically trying to show here. And just before we finish the technical elements, I want to just maybe draw your attention to some elements that you might consider next time you're out on site or assessing the site, whether yourself or your clients. What is the main driver? That's the key question initially. What is the main driver in looking at renewable technologies? PV, for example, you might have a high electrical load and you're looking to reduce your electrical costs. In solar thermal, that could be the same. You might be looking to reduce your hot water costs. You also might be just have looking to reduce your carbon impact, which is probably about 50% of the projects we do. Heat and hot water is a energy intensive process, and solar thermal can offer a very good carbon reduction to that. So that obviously contextualizes a lot of the further conversation. Practically then, just what does the existing heating system look like, and how would we potentially accommodate that with the solar thermal system incorporated? Do we need a different store? Can we use heat exchangers? And what are the details on site? What does the store look like? What does the plumbing look like? The location of the panels, where are we going to put them? Are we going to put them on the roof? Are we going to put them on the ground? Is the roof suitable? All the usual kind of things you would probably imagine assessing a site based on. And then finally, a big contributor to cost, which I mentioned earlier, is installation. How do we get the panels to site? And there are multitude of ways of doing this, but there's one of the biggest impacts on project cost is how we get, for example, on the roof. Are we using lots of equipment? Are we using lots of safety systems that are manually intensive and costly to erect? Lots of elements like that can contribute to cost. So it's not just the panels, it's the existing infrastructure, how we get into the existing infrastructure, which is probably the biggest impact on project cost. So that's me. I know this is quite a whistle-stop tour of solar thermal. I just wanted to cover as many elements that I thought may be relevant to you. We're very open to discussion. I mean, we have a few minutes for questions now, but after this, please feel free to give us a shout. Our details are here if you want to take them down. There's mine, there's Matt's, there's the general info, or you can just look us up. For any future conversations at any stage, just please feel free to talk to us. So thank you very much, everybody, and hope you found it useful, and look forward to future discussions.
Yeah, we do have a few questions in the Q&A, Fintan. You'll be glad to hear.
Yes.
So not in any particular order, but there's I think it's cropped up more than once, a question just in relation to the warranties.
Yeah, panel warranties are typically kind of the industry standard for panel warranties is typically 10 years. That's not to say that after 10 years they're done. They typically last 20 to 25 years as a common enough occurrence. And this may answer one or two of the other elements here as well. One of the big elements that we're pushing for digital side of things is to address maintenance and reduce maintenance costs, make sure the system doesn't overheat, which some systems, this was a common technology during the Celtic Tiger. and lots of people installed them but didn't maintain them. They may have overheated, which can damage the system. Basically our digital side alerts you to anything like that, records it if you can't do anything about it. And there's, in industrial applications, we can automate systems to deal with overheating. So you typically, the operation and maintenance costs as a result of measuring the system performance and just general system operation is very low as a result. And you don't need to change working fluids, you don't need to do this, that, and the other. It's a much lower risk proposition.
And that also feeds into a question, Fintan, here from Kieran. Kieran's asking, does Senergy offer an annual maintenance service for solar thermal systems? Recognising that the refrigerant system generally requires cleaning and pressurization annually. And he's finding that maintenance providers, or finding maintenance service providers is extremely challenging.
You're right, Kieran. We have a network of people that do it for us, essentially. So on existing systems, that is the case. We have a network of people we can potentially put you in touch with, depending on where you are. So let us know. Again, going back to the digital side, the whole point is to take away that annual maintenance. You're only essentially changing that fluid because it's degraded, through overheating. Things shouldn't be leaking. So if there's a leak, that's an installation issue.
Okay, just in terms of the data platform, Fintan, question here. Can you clarify for the digital platform that tracks the solar thermal generation and hot water usage, what will be the hardware installation on site?
Good question. We use digital heat meters, digital flow meters, and a multitude of other things depending on the application. So that's on the solar side, on fossil fuels or other backup heating, and then draw off, depending on how complex we want to get. We also use some novel software algorithms that we've generated. If we don't have access to places where we can put in hardware, the majority of commercial applications we can do that. On the domestic side, we use a lot of software to get a greater than 90% accuracy without the need for hardware and the associated costs. In a commercial setting, those hardware costs are quite insignificant.
Maybe just one last one here from Paul. Paul's asked a few questions. I think we've covered some of them. The first one, if a client indicates they prefer to retain flexibility and reserve the roof space for solar PV, how should this concern be addressed? I know that's something that we come up against in quite a few scenarios, Fintan.
So it was a question just around space?
Yeah. So how do we balance that requirement around if the client has a preference to cover the roof in PV?
Yeah, we get that a lot. I suppose it just comes down to demand, and what's the main driver from the client. Bearing in mind, solar thermal takes up about 1/3 of the space of PV for the equivalent kind of power output. That's a kind of key thing to keep in the back of your mind, about 1/3 of the space. So you need 3 times the space of PV typically. But again, it just depends on the demand. I mean, if your load is, if you're running a factory that is primarily electrical load, then it makes sense to do PV. If you have a hot water load, it makes sense to definitely proportion some of that area for solar thermal. The other thing to consider is, on a practical basis, our big thing is we want to reduce overall project costs. So if you're on the roof anyway, the main costs are getting people on the roof and panels on the roof. It doesn't matter what it is, so mounting systems, we can use very similar mounting systems. So again, bear in mind, there may be synergistic ways where you can reduce costs if you're doing both of those systems.
Okay, I'm going to pause there because we've come to the end of our time slot, and I just want to finish by thanking everyone. I hope you find the 30 minutes really useful and a little bit more informed about the benefits of solar thermal. We will follow up with an email with the recording. You have our contact details if we haven't addressed any of the questions that you have, and look forward to hearing from you. Thank you, everyone.
Thank you very much, everyone.